Okay, so we are trying to find out triangle ABF, and triangle ABF is equal to triangle ABD plus triangle, sorry, minus triangle FBD, right?
Right.
Correct?
Yes.
Now, we can also write this as trapezium AB, let's say B, C, D, E, F, G, H, I, and J. We can also write this as trapezium AB, H, I minus trapezium BH, AB, H, H, I is one trapezium minus the second trapezium is BH, IF, right? So the first
Right.
trapezium is this one, the whole thing, and the second trapezium is this one, ABHI and BHIF, right? Correct?
Yes, sir.
Yes.
Okay, this would make it easier. So I know this is x1, y1, x2, y2, and x3, y3. This is what we know. So that means this is x3, this is x1, this is x2, this is y2, this is y3, and this is y1. This is what I know, right? So what would be the area of trapezium ABHI? This is half into sum of parallel sides. Which are the parallel sides?
BH and AI.
BH plus AI into height. What is the height?
HI.
HI minus trapezium BHIF. Half. What are the parallel sides?
BH and IF.
BH plus IF. And what is the height?
And it would be IF.
Sorry?
FI, IF. Or sorry, HI once again.
HI,
Sorry.
right? So I can
Right.
take half HI common and I can write this as BH plus AI minus BH minus IF, correct?
Right.
So AI minus IF, right?
Right.
So this is AI half HI into AI minus IF. Let's leave it at that. Okay, let's find the other one first. So the other one is this part. So trapezium, triangle AFC is equal to trapezium AIJC minus trapezium Fijc, right? Correct?
Yes.
Hmm.
So what is trapezium Aijc? Half into
AI into CJ
plus Cj
plus CJ into IJ.
minus half Fijc
FI plus CJ into IJ.
So half Ij can be taken common into Ai plus Cj minus Fi minus Cj, right?
Right.
So half Ij into Ai minus Fi, right?
Right.
So now I'm going to add these two. Triangle AFC plus triangle ABF, right? So triangle
Right.
ABF is here, half HI into AI minus IF plus this one, half IJ into AI minus IF, right? Correct?
Yes, sir.
So AI minus IF is common to both.
Hmm.
So AI minus IF into HI plus IJ, right?
Yes, sir.
Right.
Okay. So HI plus IJ is straightforward. This is this distance. What is this distance?
X3 minus X2.
X3 minus X2. Fantastic. So this is equal to half AI minus IF into X3 minus X2. Okay. And I
Okay.
also know AI. What is AI?
Y1.
Y1 minus IF into X3 minus X2. Now I am left with only IF, right? So I can now use the concept of similar triangles again from first principles to get this. Okay. Now look at triangles CFG and CBE. Triangle CFG and CBE. So these are similar triangles, right?
Hmm.
Triangle CFG and CBE. These two are similar.
Yes, sir.
Similar. So which sides are proportional?
CB upon CF.
CB. Okay. I won't take CB. I will go with x and y ones. Okay.
Okay. Hmm.
So let's try and equate the x and y part.
Hmm.
So CG, which is the side of the small triangle, over CE, which is the side of the bigger triangle, is equal
Hmm.
to EG by BE, right?
Yes.
Yes.
Now what is CG?
X or Y 3
CG
minus.
CG is Y3 minus Y,
Yes, sir.
Yes.
and CE is Y3 minus Y2,
Yes.
right?
Right.
What is EG?
EG
Y
is.
minus Y2.
Sorry, not EG. I wrote it wrong. This is FG, this distance.
Hmm.
FG. What is FG?
X3
X.
minus X1.
X3 minus X1. And what is BE?
X3 minus X2.
So now can we find Y?
Yes, sir.
Y3 minus Y is equal to X3 minus X1 by X3 minus X2 into Y3 minus Y2, right?
Right.
I bring this term up, right? Correct?
Yes,
Yes.
sir.
So Y would be Y3 minus X3 minus X1 by X3 minus X2 into Y3 minus Y2. Correct?
Yes.
So now I found the value of Y.
Yes, sir.
So Y is nothing but IF. This is F. This is I. So IF is equal to Y,
Yes, sir.
right?
Yes.
So now I will put the value of Y in this, right? So this is Y1 minus Y, right? Correct?
Yes.
Yes, sir.
So Y1 minus Y is equal to Y1 minus Y3. In place of Y, I am writing this Y3 minus X1 minus X3 minus X1 by X3 minus X2 into Y3 minus Y2, right?
Yes.
So let us simplify this. Y1 minus Y is equal to Y1 minus Y3 plus X3 minus X1 by X3 minus X2 into Y3 minus Y2. Okay. So this is Y1 minus Y3 into X3 minus X2 plus X3 minus X1 into Y3 minus Y2 over X3 minus X2, right?
Right.
Right?
Yes, sir.
So now you see there is a x3 minus x2 term here, which is multiplied by y1 minus y. So this into this, right? Correct?
Yes, sir.
Yes.
So therefore, area of the triangle ABC is equal to half of y1 minus y into x3 minus x2, which can be written as half of y1 minus y3 into x3 minus x2 plus x3 minus x1 into y3 minus y2, right?
Yes.
Yes, sir.
So this is the final form, and we can simplify this to get um, to get it all in terms of x1, x2, y3. So this can be written as y1 x3 minus y1 x2 plus y3 x3, sorry, minus y3 x3 plus y3 x2 plus x3 y3 minus x1 y3 plus sorry, minus x3 y2 plus x1 y2. Now let's see what cancels out. X3 y minus x3 y3 plus x3 y3 cancels out, right?
Yes, sir.
And anything else cancels?
Um.
Nothing else cancels.
Right.
Hmm.
Yes.
So this is half of, I can take the y1 terms together. So x3 minus x2 plus y2 terms together, x1 minus x3 plus y3 terms together, x2 minus x2 minus x1. This is the form of the final expression. Okay, now let us look at the logic. Okay, this was long explanation. Now look at the logic. Half of y1 into x3 minus x2 plus y2 into x1 minus x3 plus y3 into x2 minus x1, right? So you see y1 3 minus 2, y2 1 minus 3, y3 2 minus 1,
Right.
Yes, sir.
right? So this is very simple to remember,
Yes.
right?
Hmm.
Is it or is it not?
It is.
It is.
Any confusion?
No.
No,
It
sir.
makes sense.
Okay.
Sir, I remember the Heron's formula now. We can use that. It'll be faster if we take out the distance and we
Yes.
use
Okay.
that form.
I'll show you the distance also. Just one second. let us look at the distance part also. If I want to do it with the distance, then I have to drop a perpendicular. This is not exactly one. So I have to drop a perpendicular from this on this line, right? This is where I can use the distance formula, correct?
Yes.
Now, how do I find this line AD?
It should be
You have to find this height, right? If I take BC
right.
as the base, I have to find this height. How do I find this height? Now, x1, y1, x2, y2, x3, y3, right?
Yes.
Yes, sir.
So I know BC. This is what?
It is x, the square root of x3 minus x2 squared plus y3 minus y2 squared.
So this is known. Now, in order to find AD, I have to understand one thing, that AD is perpendicular to BC, right? So the
Right.
slope of the line AD multiplied by slope of the line BC is equal to -1.
Right.
Okay, this is how we have to find the uh, basically we have to find the point D, the coordinates of the point D. Right? So this is uh, one thing that we have to use. The other thing that we have to use is D is a point on the line BC, right? D is a point on the line BC, right? So the slope of BD is equal to slope of BC, right? What is the slope of a line? You understand slope of a line?
Yes.
Yes, sir.
Slope of a line is, if I have a line like this AB, then the slope of AB would be this over this, which is if B is x1, y1 and A is x2, y2, then y1 minus y2 is this over x1 minus x2 is this. So this is defined as the slope of a line. The
Yes, sir.
the y coordinate, difference in y coordinate divided by the difference in x coordinate. So slope of BD is y minus y2 over x minus x2, D and D, right?
Right.
So difference of the y coordinates is y minus y2. Difference of the x coordinate is x minus x2, right? And slope of
Yes, sir.
BC is y3 minus y2 by x3 minus x2.
Hmm.
Difference of y coordinates by difference of x coordinates,
Yes, sir.
right?
Yes, sir.
Yes.
So this is the uh, the relationship between the slope of BD and slope of BC. right?
Yes, sir.
So that means the slope of the line BC is this. We don't know x and y, right? So we'll not consider this. So slope of the line BC is this one, right? And slope of line AD is equal to minus 1 over slope of BC, right? From this,
Yes.
right?
Yes.
So that is minus of, I take the reverse of this. So x3 minus x2 by y3 minus y2, right?
Yes.
Yes, sir.
So therefore slope of AD can be written as y1 minus y by x1 minus x. I'm taking the y coordinate of A and D and x coordinate of A and D, and this is equal to minus of this thing, y3 minus y2. Correct?
Yes, sir.
So from these two equations, we will be able to solve for x and y.
Yes, sir.
Right? So if I give you the values, it becomes easier because this will be lot in terms of x and y. So we can do that, but in general, it would be y1 minus y is equal to minus x3 minus x2 by y3 minus y2 into x1 minus x. Okay, from this equation, and from this equation y minus y2 is equal to y3 minus y2 by x3 minus x2 into x minus x2. And if we just add these two equations, these two will get cancelled out. So y1 minus y2, one second. So y1 minus y2 will be equal to y3 minus y2 by x3 minus x2 into x minus x2 minus, sorry, plus of minus of this. So this becomes minus x3 minus x2 by y3 minus y2 into x1 minus x, right? So this is where you will get the value of x, because all other values would be known,
Yes, sir.
Okay.
right? So after you
Yes.
get the value of x, you have to put it in one of these two equations to get the value of y. So this is how you can find out x and y of this particular point, and then you have to find AD, which is root over of x1 minus x whole square plus y1 minus y whole square, and then you have to use the formula half BC into AD. Now the reason why we don't use this is because it is much more cumbersome to arrive at.
But sir, we can do it without the height.
Sorry?
We can do it without the height. We can take First, we find out all the sides AB, BC, and CA for the perimeter. Then, for the area, we can use that formula
S,
S minus A
yeah, you can do that.
into that. That's simpler.
Yes, you can do that. You can do that very well, right?
Hmm.
But in that case, see, the reason why I showed you the first one, okay,
Hmm.
is because if you try to find out AB, BC, and CA, you still have to use the formula root over x1 square, x1 minus x2 whole square plus y1 minus y2 whole square, and you have to deal with this 3 times, right? But instead of
Yes, sir.
that, if you use this formula, y1 into x2 minus x3 plus y2 into x3 minus x1 plus y3 into x1 minus x2. If you use this formula, you can
Hmm.
straight away find it out, isn't it?
Okay, sir. Yes, sir.
So this is the simplest way. As I said,
Hmm.
there are n number of ways of doing this, okay? But the difficulty
Yes.
level varies. So if you're trying to do it with half base into height, then you have to find out the height. And the
Yes, sir.
way to find out the height is the way I showed you. You know, you have to find the slope of the base, get the slope of the height, and then um, put it in the two equations to find out x and y, which is
Yes,
which
sir.
is way too cumbersome. So this is the
Hmm.
simplest way,
Okay, sir.
Okay.
right? So
Hmm.
uh, are you confused or no confusion?
Now it makes sense.
No. Okay.
What we'll do is we'll go through this once again tomorrow, because the reason I want to emphasize on this is because when we go into dealing with multiple other things, like for example, you might be given a problem like this. There are three straight lines. Find out the area here. So this is a common problem, right? So while we get into these kind of problems, it is very important that we understand this part very clearly, so that it becomes
Okay,
very
sir.
easy. Yeah, actually, you can divide any given area into triangles and trapeziums or rectangles.
Yes, sir.
So that becomes very easier to deal with, and you can use this formula to find out areas of any figure in coordinate geometry.
Okay, sir.
Okay, so just remember this: y would be the common factor. X would always be in brackets, and it would go in sequence: 1 2 3, 2 3 1, 3 1 2.
Hmm.
Okay.
Okay, Kushal,
Yes.
confused?
No, this makes sense.
Okay. So we'll stop here, but we'll take this up once again tomorrow before we get into our next topic.
Okay, sir.
Okay,
Okay.
and I will start giving you some exercises. Kushal, just to let you know that we have a website called Quizstar, where I will add you to a class, and when
Okay.
you log in, I'll send you the ID and password. When you log in, you'll see exercises that you can do.
Okay.
Yeah.
Yes.
Any questions?
Nope. This makes sense.
Risha, any questions?
No, sir.
Okay. So when do we meet tomorrow? At 6:30, right?
Yes, sir.
Yes.
Okay. Good. So have a nice rest of your day. And I know, Kushal, it's really late for you. So we meet again at 6:30 tomorrow.
Okay,
Okay.
sir.
Okay, guys.
Thank
Thank
you.
you. Take
Thank you,
care.
sir.
Bye.
Bye.